So welcome to grade 11 chemistry. I always like to start grade 11 chemistry with a nice review of grade 9 because really in all reality, I'm sure you don't remember anything from grade 9 chemistry. So what chemistry actually is by definition, we actually just say that it's the study of matter. So matter is something that you started covering in grade 9. I'm sure you don't remember that. So let's go through and let's take a look at what matter is. So matter is said to be anything that has mass and takes up space. So anytime that I talk about matter, I just need you to remember those two things: anything that has mass and takes up space. Now in chemistry, we like to be as specific as possible, so we can actually measure these things in chemistry. We can take measurements around matter. So we can measure mass using a balance. So you might have a bathroom scale. This is an example of a balance. So we're going to use balances in class to measure mass. And space, that's actually a measure of volume. So things like graduated cylinders, that's going to help us to actually measure how much space something takes up. So we're going to be taking measurements in chemistry that's going to help us to determine things that we need to know about matter. Examples of things that could be matter: rock, water, even the atmosphere. Even though you can't technically see it, the atmosphere, so oxygen, carbon dioxide, nitrogen, all of those gases actually have mass and take up space. Matter is commonly found in three states. So the three states of matter are solid, liquid, and gas. So I put these little symbols here because these are going to help you remember it. So essentially anything that's said to be matter can exist in any of these states. However, at room temperature, there's typically an assigned state. And in chemistry, you're going to have to know those assigned states. So you're going to have to know that if at room temperature, something is going to exist as a solid, as a liquid, or as a gas. In order to tell that, you're going to be using your periodic table. So you have a copy of a periodic table I gave you, or you have the digital one that I shared with you. And in those periodic tables, you're going to see this, usually it's a cube that's used to represent solids. It's usually a little water droplet that's used to represent liquids, or it's usually this little cloud here that's used to represent gases. Sometimes it'll color coded as well too. So our periodic table we have in the classroom, anything that's a solid is black, anything that's a liquid is blue. You're going to notice there's actually only two blues on the periodic table. Bromine and mercury are the only two liquids at room temperature, and anything that's a gas on our periodic table is typically red. Now, as I mentioned before, matter can actually change state. So something that's a solid at room temperature could change to a liquid. It could be changed to a gas. It's just a matter of either adding or taking away energy. So this diagram looks kind of confusing, but it actually helps to show you how you can actually change states. So let's think about going from a solid to a liquid. A solid is said to have the lowest energy. A liquid is said to have higher energy. So in order to go from a solid to a liquid, I'm going to have to add energy. And going from a solid to a liquid is called melting. So in order for me to go from a solid to a liquid, I'm going to add energy. I'm going to call it melting. Easiest way to think about this is solid water. So I have solid water, ice, and I want to turn it into a liquid water. What am I going to do? I'm going to melt it. How do I melt it? I add heat, I add energy. If you want to go in the opposite direction, so if you want to go from kind of medium energy to low energy, well, if I want to go from liquid water to solid water, I'm going to freeze it. So we call that freezing. And in order to freeze something, I have to make it really cold. I have to take away energy. So going in this direction, we're losing energy. Now let's take a look at something that has medium energy and compare it to something that has high energy. So our medium energy is a liquid and our high energy is a gas. So if I want to go from liquid to gas, I can do that. We call that evaporation. So if I'm going from liquid water to gaseous water to water vapor to water in the atmosphere, we're going to say that that water is evaporating, evaporation. If I want to go from that atmospheric water, that water vapor, back to liquid water, I can do that. I'm going to have things cool, and that's going to be called condensation. So this here is an example of losing energy. It's called condensation. So oftentimes if you have like a water bottle, and on the outside of your water bottle, you get the water droplets, that's the atmosphere condensing onto your water bottle. So typically you only get those water droplets if something is is cold. So if your water bottle is actually cold enough, if it's like ice cold water, you can actually see it's going to condense water vapor from the atmosphere, and you're going to get that condensation on the side of your water bottle. So that represents losing energy. My favorite is the one that you probably don't see because it requires so much energy, such a big energy jump, because we're going from low energy to the highest energy. So you can go right from a solid to a gas or a gas to a solid. Why it's my favorite is because it's the same term. So we just call that sublimation. So to go from a solid to a gas, you have to add a boatload of energy. We're going to call that sublimation. And to go from a gas to a solid, you're going to take away a bunch of energy. We're also going to call that sublimation. Now, what else is there to know about solids, gases, and liquids? You have to know a little bit about their properties. So in order to describe them, we describe three things: their volume, their shape, and their compressibility. So the volume is just kind of how much space they take up, right? So the volume of a solid is said to be fixed. So for example, I've got my little pen here, and my pen is going to take up a fixed amount of space. I actually can't change how much space it's going to take up. Whereas a liquid is actually going to be variable. So a liquid is actually going to take up a variable volume. So for example, if I pour something into my mug, it is going to have the volume of the mug. Whereas if I pour the contents of that mug onto the table, I finished my coffee, don't worry, then all of a sudden that volume is going to change, and the volume is going to be the same as the puddle on my table. So for a liquid, the volume is variable, and for a gas, the volume is also variable. Shape, we say that the shape of a solid is fixed. We say that the shape of a liquid is fixed, but the shape of a gas is going to be variable. And compressibility is kind of like how much can I squeeze it, right? So can I squeeze it and actually like make an indent? So for compressibility for a solid, it's very, very slight. Most solids you actually can't squeeze and make an indent. If you have one of those like softer wood pencils, sometimes if you kind of chip at it, you can make a little dent in it, but you can't actually flatten the pencil. A liquid is said to have slight compressibility, and a gas is said to be very compressible. Let's talk a little bit about changing from a solid, a liquid, or gas. So changes in state are said to be examples of physical changes. So if I go from a solid to a gas, I'm said to undergo a physical change. Now, a reminder from grade 9, what a physical change is: that's going to alter the appearance, but it's not going to alter the composition. So for example, if I go from liquid water to solid water, ice, it's going to look different. So liquid water is that clear kind of flowing thing. Solid water is ice, so it's got that fixed shape. Sometimes you get that kind of frosty white. It kind of goes opaque a little bit. So it's going to look different, but the chemical composition is still going to be the same. So the chemical composition is still going to be 2 hydrogens bound to 1 oxygen. So we say that physical changes do not result in the formation of a new substance. Here we have a different looking substance, but when we actually look at the chemical structure, the structure of the substance itself is still the same. Chemical changes, on the other hand, are going to convert the substance into different form or forms of matter. So depending on how many reactants you have and how many products you have, it's going to convert it into different form or forms of matter. So for example, a chemical change might be the electrolysis of water. So if you take liquid water and you run a bit of electricity through it, you're going to see it's actually going to separate out into hydrogen gas and oxygen gas. So not only are my products going to look different, but now I know that I actually have 2 different substances or 2 new substances that have been formed. So I no longer have 2 hydrogens bound to 1 oxygen. I have 2 hydrogens bound to themselves, hydrogen gas, and I have 2 oxygens bound to themselves, oxygen gas. So we say that these result in a new substance. So chemical changes are going to result in a new chemical substance. Common examples you might remember from grade 9, burning, rusting, baking bread. We also have the evidence of a chemical change. So I'm sure you remember this from grade 9. If you don't, you looked at it in grade 10. You don't remember it, definitely remember it, because we're going to use it pretty much every lab that we have this semester. So this is going to be what you're looking for the signs of a chemical change. In grade 9, we gave you 5 or 6. Here I've condensed it to 4, but notice that everything's still going to be on the list. So evidence of a chemical change, if we have an energy change. So if we have an energy change, that energy change might be heat or that energy change might be light. So in grade 9, these were 2 different steps. Now I've just put it into one step. So if you have I'm clearly hungry. If you have heat given off, it's going to be an example of a chemical change. If you have heat taken in, so if something feels cold, it's still going to be an example of a chemical change. If you have light given off, a really bright light given off, that's also an example of a chemical change. Another sign of a chemical change is the formation of gas or bubbles. So the formation of gas you can't see because most gas is clear and colorless. However, you typically can see bubbles forming. So the formation of gas is going to be the sign of a chemical change. Formation of a precipitate. Now, if you don't remember what a precipitate is a solid forming from 2 liquids. So you have 2 liquids that are mixing together. And if you have those 2 liquids that mix together and they form an unexpected solid, that's a precipitate. And then the last but the most obvious thing you're looking for is a color change. So if you see an unexpected change in color, if you see an unexpected change in color, that's an example of a chemical change. Now, notice I said unexpected change in color. So if you paint something green, that's not an unexpected color change. If you put green food dye in something, that's not an unexpected color change. But if you have 2 clear things that mix together and form a red thing, that's an unexpected color change. So you want to see a color change that you wouldn't expect to see. Now let's take a look at how to classify matter. So we have different ways that we can go ahead and define or sort matter. And this is actually going to help us to kind of define some of the units of chemistry we're going to look at. So matter, first of all, can be sorted into homogeneous or heterogeneous. So those of you that have had bio already, you're going to recognize these roots homo and hetero. They come up in bio, they come up in chem. Essentially, homo just means the same, hetero means different. So hetero is 2 different types of matter. Homo is 2 of the same types of matter mixed together. Homogeneous matter, we can then separate into 2 categories, pure substances and solutions. We're going to talk about definitions of each of those. And then pure substances can then be defined into elements and into compounds. So let's look at some of these definitions. Let's start with the definition of a mixture. A mixture is a combination of 2 or more substances. So if we're discussing a mixture, we're talking about 2 or more substances. You can have 2 types of mixtures, heterogeneous or homogeneous. So we've got our 2 mixtures, heterogeneous and homogeneous. Remember, homo just means the same, so it has only one phase. There's the same phase within it. By phase, I mean solid, liquid, or gas. So a homogeneous mixture is going to have one phase. A heterogeneous mixture is also called a mechanical mixture. It has 2 different phases. So the example that we gave you in grade 9 is if you have a heterogeneous mixture if you can see 2 different phases. So a great example of a heterogeneous mixture is like trail mix. I can see lots of different things in trail mix. Therefore, I know I have lots of different parts. It's a heterogeneous mixture. A homogeneous mixture is if you can't see a difference. If you can't see a difference, if it only has one phase, then it's said to be a homogeneous mixture. We then split homogeneous mixtures into solutions and pure substances. A solution is a mixture that contains 2 or more substances. So let's think of a really good solution right now. A really good solution, you're looking at it right now, is air. So air is made up of a bunch of gases all in the same phase. So you might have nitrogen, oxygen, carbon dioxide. You're looking at all of those things right now. They look to be the same to you. They're a clear colorless gas. They're all in the same phase, but it is a mixture of different substances. So homogeneous solutions are 2 or more substances combined together. You can also have a compound. A compound is still a pure substance, but it's consisting of 2 or more elements bound together. So now we're looking at pure substances. I'm actually going to help you with the definition of pure substances here. So a pure substance can make up 1 or 2 things. It can be a compound. A compound is 2 different types of elements that are bound together. So let's call this water, right? We have 2 hydrogens, we have 1 oxygen. So this is considered to be a pure substance. It's made of elements that are actually chemically bound together, whereas an element is made up of two or more, or you can even just have one atom bound together. So elements are the same type of atom, compounds are a different type of atom. So that's kind of a visual way for you to tell the difference between elements and compounds. Down here, we just have the definition of a compound, two or more elements or two or more atoms bound together. Let's remind ourselves one more thing that we're going to need to know for labs as we go through this year, and that's going to be the difference between physical properties and chemical properties. So oftentimes I'm going to ask you to describe a substance. The reason I ask you to describe a substance is because you're going to be looking for changes. If you don't describe what something looks like to start, you're not going to understand if a change has occurred. So one way that we can describe a substance is using something called physical properties. So what physical properties do is they describe an object without actually changing the substance. So you can go ahead and you can define a substance's physical properties without actually making any changes to it. So again, you have my pen. So you can actually describe what this pen looks like, right? It's gray, it's shiny, it's a solid, and I didn't actually make any changes while describing what it looked like. There is a lot of physical properties. So in your lesson, in your link, I actually just provided you with this list. So you might want to print this list or store this list because I'm always going to ask you for physical properties during a lab. You're going to want to have a couple go-tos. So easy ones are things like color. Texture, you're not always going to be able to touch things in a lab, but even without touching things, you can sometimes tell what the texture is. If it looks like it's fine, if it looks like it's smooth, if it looks like it's gritty. You can also define the odor of something. Remember, we always waft in chemistry, so you're never gonna stick your nose right in something. You just kind of waft it towards yourself. You can describe to me what something smells like. Luster is how shiny something is. So you're gonna tell me if something is shiny, dull, or matte. Clarity is how clear I can see through something. So if I can totally see through something, we say it's transparent. If I can kind of see through something, it's translucent. And if I can't see through something, it's opaque. Taste, you're never going to taste anything in a lab, but if you were tasting things, it would be a physical property. Viscosity is how easy a liquid flows. So if a liquid is very viscous, it's very thick. If a liquid is non-viscous, it's not thick. Malleability. The definition of malleability is the ability to be hammered into thin sheets. I like to think of it more as bendability. So for example, aluminum foil is very, very, very malleable. We can put it into a thin sheet, but I can also bend it easily with my hands. Whereas a steel beam is not very malleable because I can't actually move or manipulate it. Ductility is the ability to pull something into a wire. So things, metals, this applies to metals. Metals that typically would make up wires would be things like copper wiring. Nickel can also be something that's got ductility. Hardness is the resistance of a substance from being scratched. So in real chemistry, we actually go through and we have a 1 to 10 scale, 10 being something that's really hard, 1 being something that's really soft. In this class, I just recommend that you either tell me something is hard or something is not hard. So if you can touch a substance and it doesn't really move at all, it's got a high hardness. If a substance, if you touch it and your finger goes right into it, then it would be considered to be a soft substance. Conductivity is something that you can't actually see, but we are able to measure it without changing the substance, so it is still called a physical property. So conductivity, we use something called conductivity testers, or you could actually just use a good old-fashioned light bulb and some wires, and you're able to tell if a substance can conduct heat or electricity. So you can actually use a conductivity sensor to go ahead, place it, it's a little probe, you place it into your liquid, and it's gonna tell you if a substance has high or low conductivity. Since measuring this only involves placing a probe into a substance, it's still a physical substance, or still a physical property, even though you can't see it with your eyes. The last thing that might be considered to be a physical property that, again, you can't see with your eyes, but you can still measure is density. Density is the mass per unit volume. So you can absolutely decide something's mass using a balance, and you can absolutely measure something's volume either using a tape measure or using a graduated cylinder. You can divide these two things, and that's going to tell you density. So essentially, it tells you how compact something is. If something is very dense, it's very, very, very compact. You have a lot of mass packed in a very little volume. If something is not dense, it's not compact. So you have little mass or a very large volume over a bigger surface. So density, again, you can't actually look at with your eyes. You have to measure it. But since we're not making any changes to the substance, it's still considered to be a physical property. So this list here, again, might be handy. You have to know this. So in a lab, I'm going to ask you for physical properties, and you're going to pick like 3 or 4 or 5 physical properties, and you're going to report on them. Obviously, some of them are harder than others. So you're probably not going to be reporting on conductivity or density. You're probably going to be reporting on closer to the top of the list. Last thing we want to look at is this idea of a chemical property. So a chemical property is still me describing a substance, but now I actually have to make a chemical change to test it. So I actually have to have a chemical change undergo the substance to describe this property. So you always want to measure physical properties first before you measure chemical properties, because once you start measuring chemical properties, there's really no going back. So for example, combustibility, how likely something is to catch on fire. I might have to catch it on fire. So that substance is going to change. It's going to involve burning. It's not going to look the same anymore. So a chemical change is required to tell this. Rusting is another example of a chemical property. Reactivity is another example with a chemical property. So we don't tend to report on these in class, but if you ever are researching a substance, typically its chemical properties are available to you, and it's usually pretty useful in chemistry because it's going to help to tell you how something is going to react with something else. So that's kind of your crash course start for chemistry. That's what matter is. And remember, chemistry is the study of matter. Next video, we're going to remind you of the scientific method. And the scientific method is what we're going to be using to study chemistry. So we'll see you in the next video when we talk about scientific methods.